Welcome to the fourth lesson in Session 7 on translations and dilations. So to review, a transformation is the general term for four specific ways to manipulate the shape of a point, a line, or a shape. The original shape of an object is called its pre-image, and the final shape and position of the object is called the image under transformation. The four types of transformations include the rotation, the reflection, the translation, and the dilation. A transformation is isometric if the pre-image and the image are congruent. Three of the four transformations are isometric, and they're the rotation, the reflection, and the translation. The dilation is not an isometric transformation. And a composition of transformations is when two or more transformations are performed on one object. A translation is a transformation that slides every point of an object the same distance in the same direction. Notice the object is not rotated, reflected, or resized. It simply slides from one location to the next. The notation that we're going to use is a capital T followed by what appears to be a coordinate, and there is an X value and a Y value. The capital T indicates that the transformation is a translation. The X indicates the value that is being added to each X value of the object. So we look at each coordinate and we add X to the X values of the coordinate, and we add Y to the Y values of the coordinate. So the X and the Y that are used as a subscript with the capital T indicates we have a translation, and the X and Y indicate how much we're going to add and subtract to the X and Y coordinates of the image. So some examples: if we have a translation 2, -3, tells me that the translation adds 2 to each X value of the image and -3 to each Y value of the image, or the pre-image, excuse me. T with a -1, 6 indicates a translation that adds -1 to each X value of the pre-image and 6 to each Y value of the pre-image. A capital T with 0 and 4 indicates we have a translation that adds 0 to each X value of the pre-image and 4 to each Y value of the pre-image. And lastly, if you have -7 and 0, indicates we have a translation that adds -7 to each X value of the pre-image and 0 to each Y value of the pre-image. So in our example, we're going to perform the indicated translation on the trapezoid that we have here. It's quadrilateral ABCD, where A is the coordinate -6, 4, B is the coordinate -3, 4, C is the coordinate -6, 1, and D is the coordinate -1, 1. And we're going to perform the translation 8, -4. So what I need to do is I need to slide each coordinate of the image 8 units to the right and 4 units down. So I need to add 8 to each of the X values, and I need to add -4 to each of the Y values of the pre-image. So doing so provides me with new coordinates, A prime, B prime, C prime, and D prime, where A prime is 2, 0, B prime is 5, 0, C prime is 2, -3, and D prime is 7, -3. So notice that the trapezoid is congruent from the pre-image, so it is a isometric transformation. The last transformation we're going to study is the dilation. And the dilation is a transformation that produces an image that is the same shape as the original, but is a different size. So the dilation is not an isometric transformation. The description of a dilation includes a scale factor. So the scale factor is the ratio that all points in an object are multiplied by. The notation is use a capital D and a subscript X, where X represents the scale factor. And again, the scale factor is the ratio that all points in the object are multiplied by. So D sub 2 represents a dilation with a scale factor of 2, where each X and Y coordinate in the pre-image are going to be multiplied by 2. d sub 1/3 represents a dilation with a scale factor of 1/3. So each x and y value in the pre-image would be multiplied by 1/3. Dilations, as we said previously, are not isometric transformations, but they will create similar figures. So remember, the angles will be congruent and the sides will be proportional. So we're going to perform the indicated transformation, d sub 3. So I have it's this type of irregular five-sided polygon, pentagon, and the pre-image, I have the coordinates A is the origin, B is the coordinate 1, 1, C is the coordinate 3, 1, D is the coordinate 3, -1, and E is the coordinate 1, -1. So I need to multiply each x value and y value by the scale factor, which in this case is 3. So multiplying each x and y value coordinate by 3 produces the image using the following coordinates, where A prime is still at the origin, B prime is at 3, 3, C prime is at 9, 3, D prime is at 9, -3, and E prime is at 3, -3. So as you can see, the two images are completely different sizes, but they are the exact same shape. So dilations produce similar objects, where the other three transformations are isometric, meaning they produce congruent objects. Lastly, we're going to perform a composition of transformations. So we need to translate the reflection in this case. So we make sure that we do the reflection first, the transfer, and the translation second. So I have a triangle ABC, and the first thing I need to do is reflect that triangle over the line x equals 0. So remember, the line x equals 0 represents the y-axis. My pre-image has the coordinates -4, 2, -2, 4, and -2, 1. Now when I reflect those three coordinates over the y-axis, my image is as such, where I have the coordinates 2, 1, 4, 2, and 2, 4. Next, I'm going to perform the second transformation, which is the translation, where each of these objects gets shifted 0 units horizontally and 4 units down. So the triangle is going to shift 4 units down, producing my final image as such, where A prime is 4, -2, B prime is 2, 0, and C prime is 2, -3. So that wraps up session 7. Good luck on the quiz and good luck on the test, and please email us if you have any questions.